We're going to discuss about limits, the definition of limits, as well as the first topic, which is the limits at finite points that have finite values. So definition of limits. In mathematics, the limit is the y value that a function approaches as the x input approaches some value. These limits are essential to calculus and mathematical analysis in general, and are used to define continuity, derivatives, and integrals. In formulas, a limit is usually written as follows, and is read as the limit of f of x as x approaches c equals L. So let's have some example about the definition of limits. So if limit of fx when x approaches 1, x plus 3. So when x is approaching 1, so we have values of x and the value of fx approaches 1. So if we have 0.9, our fx will be 3.9, because if we have 0.99, you will have 3.99. If you have 0.999, you will have 3.999. So as you can see, this one approaches to 4 when your x is getting closer to 1. If we go to the other side, if we have like 1.1, our fx will be 4.1. If we have 1.01, our fx will be 4.01. And if we have 1.001, our fx will be 4.001. So the same, when your x is approaching 1, your limit or your fx is approaching 4 as well. Or simply, you can have limit when x approaches 1 of fx is equal to x plus 3. You can just simply substitute. So you will have here 1 plus 3 is equal to 4. So the limit is equal to 4. So that's basically the definition of limits. When x approaches the value of c, the limit will be equal to L. Okay, so let's go to the first subtopic, which is limits at finite points that have finite values. So example number 1, we will have this type. If you have limit of 3x squared plus 4x plus 1 when x approaches negative 1. We will try first to substitute. So the limit will be equal to 3 times negative 1 squared plus 4 times negative 1 plus 1. That will give equal to 3 plus minus 4, minus 4 plus 1 is equal to 0. So the limit will be equal to 0 when we try to substitute. Let's have another example. The limit when x approaches 2 of the function 2x squared plus 3x plus 1 all over x. So we try to substitute. You will have 2 times 2 squared plus 3 times 2 plus 1 all over 2. So we will have now 2 to the power of 2 is 4 times 2 is 8 plus 6 plus 1 all over 2. That will give you equal to 15 over 2. So your limit will be 15 over 2 by just simply substituting the value. But there will be some types like this. Let's try this one. Example B, number 1. If you have the limit when x approaches negative 1 of x squared minus 1 over x plus 1. Let's try to simply substitute. So you will have your negative 1 squared minus 1 over negative 1 plus 1. But this one will give us equal to 0 over 0, which is your denominator can be 0. And this is what you call the indeterminate form. So if you have a value like this, you have to check if you can simplify the function. So if you have limit when x approaches negative 1, this one, the x squared minus 1 can be factor into x plus 1 and x minus 1 over x plus 1. So you can cancel the x plus 1 and x plus 1. So what you have remained is x approaches negative 1, x minus 1. So you try to substitute now the value of x. So you will have your negative 1 minus 1, negative 2. So your limit will be negative 2. Let's have another example for this one. Number 2. If you have like the limit when x approaches 1 of the function 7x squared minus 4x minus 3 over 3x squared minus 4x plus 1. Let's try if you're going to substitute the value of x right away. So you have 7 squared, 1, 4 minus 1 minus 3 all over 3 times 1 squared minus 4 minus 1 plus 1. That will give us 7 minus 4 minus 3 and 3 minus 4 plus 1 in the denominator. It will give us 0 and 0 again. So we have to factor or simplify the function first. So the limit when x approaches 1, the 7x squared minus 4x minus 3 can be factored into 2, which is 7x and x and 3 and 1. So this one will be plus 3 and minus 1. How about the denominator? We can factor out into 3x and x, 1 and 1. So you will have your minus 1 and minus 1. Then you can cancel the x minus 1 and x minus 1. So what remains now here is the limit of x when x approaches 1 of the function 7x plus 3 over 3x minus 1. Then substitute the limit of x is equal to 1, so you will have 7 multiplied by 1 plus 3 over 3 multiplied by 1 minus 1. This one will give you 7 plus 3 over 3 minus 1 is equal to 10 over 2 is equal to 5. So the limit of that example is equal to 5. Okay. So let's have now another example. Let's call it now the example C, number 1. If you have now limit when x approaches 9 of the function root x minus 3 over x minus 9. As you can see, if you're going to just simply substitute, you will have here negative 9 minus 3, square root of 9 minus 3 over 9 minus 9. That will give us 0 and 0 also. So if you have like square root function like this is how are we going to do. So if you have limit when x approaches 9, the root x minus 3 over x minus 9, we have to multiply by the conjugate of the numerator. So you have root x plus 3 over root x plus 3. So the numerator will be root x times root x, so you will have only x minus root x times 3, that will give you plus 3 root x, then negative 3 times root x, you will get negative 3 root x, and negative 3 times positive 3, you will have minus 9. And for the denominator, I will just leave it as is. I will not do the FOIL method here. So you will get here 3 root x minus 3 root x. This one will become 0. So this one will become only x minus 9 in the numerator, and you will have x minus 9 in the denominator as well as the root x plus 3. Then you can cancel this one. So you will, what remains now will be limit of x approaches to 9 of the function 1, because this one will become 1. And then you will have your root x plus 3. So substituting, you will have 1 over root 9 plus 3. So you have 1 over 3 plus 3, 1 over 6. So our limit for this question is 1 over 6. Let's have another example for this type of question. Another with the square root. So example number 2, limit when x approaches 3 of the function root x plus 1 minus 2 over x squared minus 9. If we are going to substitute directly the value of the limit x, the x approaches 3, it will give us another 0 over 0 here. So for here, we're going to simplify by multiplying by the conjugate of the numerator. So you have root x plus 1 plus 2, and root x plus 1 plus 2 as well. So the limit of x approaches to 3. We do the numerator. So you have here root x plus 1 and the root x plus 1 multiply. So you will have here x plus 1. Minus plus 2 root x plus 1 minus 2 root x plus 1 and minus 4 all over. Again, this one I will not do the FOIL method in the denominator yet because we're going to simplify the numerator first. So the numerator will have 2 times root x plus 1 minus 2 root x plus 1. So this one can be cancelled. So we will have only x plus 1 minus 4 over x squared minus 9 and then root x plus 1 plus 2. So the numerator will be simplified at x minus 3 and the denominator, the x squared minus 9 can be factored out as x plus 3 and x minus 3. Then you will have root x plus 1 plus 2. The x minus 3 can be cancelled. So the remaining function will be, this one is equal to 1. So 1 all over x plus 3 and multiplied by root x plus 1 plus 2. So substituting 3, so you will have 1 over 3 plus 3 multiplied by 3 plus 1 plus 2. That will give us 1. This one will give us 1 over 6 and plus 4. That will give a 1 over 24. So the answer here will be 1 over 24 for question number 2. That's how you do the function with the square root. And let's go to the letter D example. Number 1. If you have like limit when x approaches 3 of the function 1 over x minus 1 over 3 all over x minus 3. As you can see, if we can just simply substitute the value of x of which is 3, we will come out with a 0 and over 0 as well, or the indeterminate form. So in this type of complex fraction, we are going to simplify this one by multiplying the function by the common factor of the denominator, which is the x and 3. So multiply this by 3x and 3x. So the numerator will become 3x times 1 over x. We will just give you 3. And 3x multiplied by 1 over 3, you will get only negative x over your denominator of 3x multiplied by x minus 3. As you can see, the 3 minus x and x minus 3 are quite similar. So the numerator, you can take out the negative 1. You will have then x minus 3, and you will have here 3x, x minus 3. Then we can cancel x minus 3 and x minus 3. So the remaining or the resulting function now, when the limit approaches 3 is equal to negative 1 and 3x. Substituting, so you will have negative 1, 3 times 3. So the limit will be negative 1 over 9. Let's have another example involving complex fraction. So this time it's a bit quite complex. So the limit on x approaches 0 of the function 1 over 3 plus x, 1 minus 1 over 3 minus x, all over x. As you can see, if you're going to substitute directly the 0, we will have 0 over 0. So again, in this type, we're going to multiply by the common factor of the denominator of the fraction. So you will have it multiplied by 3 plus x and 3 minus x, and also the denominator by 3 minus x and 3 plus x and 3 minus x as well. So the resulting numerator here, so you have 1 over 3 plus x multiplied by that, you will have only 3 minus x minus 3 plus x all over. I will not combine that one, the denominator. I just leave it that way. So in the numerator, you will have here 3 minus x minus 3 minus x all over x, 3 plus x, and 3 minus x. So the resulting function now in the numerator, you will have here 3 and minus 3 is 0. So you will have here negative 2x over x, 3 plus x, and 3 minus x. Then you can still cancel the x and x here. So the resulting will be negative 2 over 3 plus x and 3 minus x. So substituting, the limit will be negative 2 over 0 plus 3 plus 0 multiplied by 3 minus 0 equal negative 2, 3 multiplied by 3, so negative 2 over 9. So that is our limit for that second question. So we have discussed here already the different examples of limits at finite points that have finite values. We have the direct substitution. We discussed the indeterminate form, wherein we can simplify the function first, involving radicals or the square roots, as well as complex fraction. So I hope you understand the basics of the limits, and in the next video I'm going to discuss about the limits at infinity, and I'll see you in the next video then. Thank you.